Hey guys, welcome to lesson 2, part 2. And yesterday's lesson in part 1, we talked about kind of bridging the gap between what we've been talking about and solving these trig equations. Well, today we're just going to talk about techniques in solving. So we're going to stay in this realm right here. So the first thing that I want to talk about is the AC method, and this is basically just factoring. So you don't have to do AC, just whichever way you factor in whatever way makes the most sense to you. Something I want to point out before we get started, this is going to be in Radian mode. Notice the 0 pi to 2 pi. And then this is going to get sloppy. So when you are factoring, remember, set everything equal to 0. So I personally don't look at it in terms of this form. I look at it like this. So if that makes more sense to you, go ahead and do this, and then we'll bring that tangent back in. But this kind of helps my head factor a little bit easier. So I'm just going to move everything over and set it equal to 0. So I have 3x squared minus 2x minus 1. So go ahead and solve for that. Okay, so you should have gotten x equals negative 1/3 and x equals 1. So we're going to go ahead and substitute that tangent back in. So I'm going to say that tangent of x equals negative 1/3 and tangent of x equals 1. So then I'm going to go ahead and solve for it. So remember yesterday we talked about to get rid of this tangent, to get the x by itself, I'm going to multiply by the tangent inverse. So what happens is these cancel, and I get x equals tangent inverse of negative 1/3. Okay, same thing over here. So I'm going to multiply this by tangent inverse. And so I get x equals tangent inverse of 1. So that is the next step when you do that. Okay, so then I always ask myself, like, is this on my unit circle? And if it is, then I can use that. But if it's not, this just becomes a calculator problem. So go ahead and get your calculator out, and I will too, and make sure that it's in radian mode. So tangent inverse, and remember from yesterday what I said, I go ahead and just make it a positive. So my reference angle is 0.322. Okay, so then I need to, that's a hideous 3. Hold on, let me fix it. So then I need to go back and figure out, okay, well, this is negative. So where's tangent negative? So tangent's positive here and negative in second and fourth quadrants. So that's what I'm doing. So I'm going to say, so in the second quadrant, I'm going to say pi minus 0.322. And in the fourth quadrant, I'm going to say 2 pi minus 0.322. Okay, so in the second quadrant, when I do that, I end up getting 2.82. And in the fourth quadrant, I end up getting 5.96. So those are my two values for this, -3. But then I'm going to come over here. Now, it's interesting because this is on the unit circle. And so I'm just going to kind of treat it a little bit differently. So it's a positive. So I know I'm going to be dealing with quadrants 1 and 3. I know that in quadrant 1, again, looking at the unit circle, it's pi over 4. And then in quadrant 3, it's 5 pi over 4. So for this equation, I actually have 4 values of x that will work. So I have 1, 2, 3, and 4. Okay, so what I want you to do is at this point, I just want you to factor this and solve for x and kind of get there. So I'm going to push pause. Go ahead and do that part on your own. Okay, so the two values you should have gotten for x is 1/2 and -7/5. And so I'm going to go ahead and substitute in sine of x equals 1/2, and then sine of x equals -7/5. Okay, in order to get rid of the sine, I'm going to multiply both sides by the sine inverse. And so I'm going to do this one, you can do this one. So these cancel, and I'm left with x equals sine inverse of 1/2. So I don't know about you, but this 1/2 is jumping out at me. I know that it's going to be on the unit circle. So I checked the unit circle. I know that sine is positive in 1 and 2. So that is where I'm looking on the unit circle. So in quadrant 1, it's a 30-degree angle. So it's going to be pi over 6. And then in quadrant 2, it's going to be 5 pi over 6. Okay, so I'm going to tell you that this one is a calculator one. See if you can do that one on your own. Okay, so you should have gotten stuck here because if you type that in your calculator, it's going to give you some kind of error, domain error, and this is what we talked about yesterday. This is greater than 1. So remember, I don't care about this sign. Just 7 over 5, that's bigger than 1, and sine can't be that. So it's no solution. So be on the lookout for that. Okay, let's go to our second method, which is GCF. So if you can factor out a greatest common factor, do it. And this is going to be our domain, so that is going to be in radians again. So this one, you can or cannot substitute it. I'm going to go ahead and just leave it as is to kind of show you just a different method. Sometimes I like to substitute it, sometimes I don't. So I see that this has a secant of x in common. So it looks like that. So again, this might kind of trip you up a little bit, but this is equal to 0 and this is equal to 0. So I'm going to say the secant of x equals 0 and the secant of x plus 4 equals 0. So I'll move that 4 over. So the secant of x equals -4. Okay, so secant of x equals 4. So I don't like that. I like thinking about it as the cosine of x. So in this case, it would be undefined. So let's see. Cosine of x undefined, that doesn't happen anywhere. Because think about this. I'm looking for my x value as undefined, and it doesn't happen. So if this were like undefined and this were 0, that would be a different case. So again, this is no solution. So this one I can do because when I flip it, sorry, when I flip it, goodness gracious, hold on a second. Okay, that's what I meant to do. It's going to be that. So when I take the cosine inverse of both sides, that is totally okay because it's under 1. But it is not on the unit circle. So I'm going to go ahead and type this in, and notice that cosine is negative here in quadrant 2 and in quadrant 3. So let's go ahead and get the reference angle. So cosine inverse of positive 1/4 is about 1.32. And so I'm going to take, in this quadrant 2, I'm going to take pi minus 1.32, and that's going to give me my angle in quadrant 2, which ends up being 1.82. And then in quadrant 3, I'm going to do the same thing, except I'm going to add the 1.2. It ends up being 4.46. Okay, go ahead and try this one on your own. See how far you can get with it. So I'm going to kind of give you a head start and see if we end up in the same spot. Okay, so this one actually has three pieces to it, and I'll show you how I got there. So the first thing I did was I factored out a sine of x, which gave me that, but then this is that perfect square binomial. So that broke up into these two parts here. So when I split this up, I have sine of x equals 0. I have sine of x equals 1 because I just moved that 1 over. And then I have sine of x equals -1. So again, I'm just solving for the sine of x, and I moved that 1 over. Okay, so I have three pieces here. Okay, so I'm going to multiply both sides by the sine inverse, and I get x equals sine inverse of 0. Okay, so let's think about this. So I'm looking for, I'll do the same thing I did a while ago. I'm looking for where y equals 0. So here and here. So I'm going to actually have two answers. So think about radians. So it's going to be 0 and pi. Okay, so for this one, it's going to be sine of x equals 1. So I'm looking for that y as 1, which is this one. So that's going to be pi over 2. And then this one is y equals -1 down here, which is 3 pi over 2. So I actually have 1, 2, 3, 4 answers there as well. Okay, so see if you can do this one all the way on your own, and I'll work through my steps and see if we end up in the same spot. Okay, so both of these are kind of repeats of things that we've had, so hopefully you saw that already. But I ended up with, well, first of all, I factored out a sine of x, and so I got these two pieces. So sine of x equals 0, and 4 cosine of x plus 1 equals 0. And this one we just had right here. So my answer is 0 and pi. And then for this one, we also had 2. I don't know if you remember it, but up here, cosine inverse of -1/4, cosine inverse of -1/4. And so I just kind of stole the answers from before. So we do have a couple more techniques that I will talk about in the next video, but for right now, we're done.